Hello everybody. Today we're going to talk about designing and picking pressure sensors and how to just generally design things. So the first thing you do is you go get you some free software, and I'll put it up here. It is Express PCB. You Google that and you download this software, and up will come something that looks like this. So the first thing you want to do, and first of all, let me just say, here are the tools on this side of the board. And the first thing you want to do is you kind of want to get an idea of what you want to do. And here's what I suggest you do: is in general, kind of block out what you want. Well, the first thing we want is a pressure switch, right? So you go click this tool right here, and it's going to draw a box. And we're going to just label this pressure switch. And I already know that this is going to be a little small, so I'm going to go make this a little bigger, and we're going to place it right here. So the next thing we want to do is this pressure switch is going to connect to something. So we're going to put the box over here, and here's the tool for the box, and we're just going to put the box in here. And I'm going to draw it a little different. Because we've told you we want to play with Arduinos, we're going to label this thing right here. And we know this thing has got to, this Arduino has got to talk to something, so it's going to, we're going to assume that at the initial beginning it's going to talk to a PC. So we go get the box again. And we're going to label this thing just a PC. Now notice on a schematic, first of all, you as engineers should get very comfortable with schematics. One of the mistakes some of the students make is that they initially go to the lab and start putting things together. I've got an almost absolute rule: don't come into the lab to put things together without a schematic. Now, on this thing, notice I've kind of lined it up where the things will flow from left to right. So the first thing we do is we're going to sense the pressure. We're going to bring it to a microprocessor, and then we're going to bring it some sort of output. So notice how it flows really easy, left to right. So now let's start to think of some characteristics on the pressure switch. Well, one of the things we know is that it probably needs to read pressure in the from 0 to maybe 3 psi. Pounds per square inch. So we're just going to put it down over here. What are some of the other characteristics we would like on this pressure sense? Well, we'd like the applied voltage to be in the range of 3 volts. And how do we know that? Well, at this juncture, we really don't know that, but typically low current, low energy systems run on low voltage, and it turns out that 3 volts is probably a pretty good 3-volt system is probably pretty good for solar panels. So we're going to take a stab at it. We're just going to say we'd like it to run on 3 volts. We'd like it to be so we'd also like it to be low energy consumption. And we would like it to be reasonable in cost. We would also like it to have a digital output if we could find one. And the next thing is, which you always need to think about, is it's available. So I'm going to kind of just square this up a little bit. Notice I've got this tool, so the select tool here, and I can just click on it and move it. Makes it kind of neat. Okay, now we've got some characteristics on our sensor switch. So now let's go find one. Well, one of the neatest things around is an outfit called DigiKey. So we're going to pull up DigiKey on, right, and we're going to type in pressure switch. Pressure sensor. And we scroll on down here, and this guy has got 21,000 pressure switches in his catalog. Now we come down to what we call a parametric search. Alright, so we come over here and we can start to pick some characteristics in here. And so I'm going to slide over here and I'm going to go pick one. Let's start with the operating pressure. So we slide on down here. This one, let's see, goes to plus or minus 3 psi. So let's try that. So let's try a search on that. We come over here. We apply the filters. Now here are the devices down here. And here's some of the characteristics. So these two devices operate plus or minus 3 psi. The output is a voltage that doesn't quite meet our criteria. This thing is outside our supply range. We would like to have something that runs on 3 volts. These are 5 volt parts. And over here we can order them one at a time, and they're $13 for these two devices. Now I've searched a lot. I spent about an hour searching. These turns out to be the closest ones I had patience for to find today. If you're diligent, you look hard on the internet, you use other search engines, you might find a better device. But because I want to put something out to you, let's just pick this guy. And down here comes the opportunity to look at the data sheet. Let's see, here's the data sheet. So we're going to download the data sheet. I can't quite get all this on the screen, so we come down here and here's how it looks. We would like something like this where we can pipe up to it. That's what we'd like. Here they tell us that the current is 7 mils. That's probably okay. They tell us that it's output voltage. In other words, there's going to probably be that probably puts out a voltage proportional to pressure, and that's 4.5 volts. It only takes 20 seconds to to warm up. That's cool. And if we carefully read all this data sheet, it'll tell us a lot about the the temperature sensor. Now, here's how you hook it up. You apply voltage to pin 2, a ground to pin 3. Voltage from 0 to 4 comes out. If we read all of this stuff, it tells us the output, and look, there's 3 curves in here. My guess is this is the accuracy. In other words, the device is, because this is a fairly inexpensive device, device to device may vary in here a little bit, so that's some sort of accuracy which will be reflected. Again, here's how to hook it up, and they're recommending we put some capacitors on the voltage in the output supply. This is a temperature spec curve. So there's some sort of error factor. In our temperature range of 0 to 80 is a factor of 1. That tends to say that's probably okay. Alright, and here are the mechanical details. So this sensor, not quite what we want, but probably okay.
NPXB 7025.
So let's get back to our drawing over here. Let's see, I'm going to try pasting this in, see if it messes me up here. Nope, can't put it in. So let's assume that we want to run this system for, well, first of all, we can test this at 5 volts. And this is a test schematic. But, so let's start to hook it up. So we know that there's, we know that there's 4 connections in here, so, or 3 connections. So let's start to put some lines in here. So we're actually going to draw a line between here and here, which is the output sensor to the device. We know we got to bring some voltage into it, so we're going to put a line out here. And we know we got to hook a ground to this sensor. So now let's go find some of these parts. So here's where we go select the parts from the library. You click this little device down here, and you come down here and you come on down to I don't remember where the power connections are. Here we go. So we got to put a ground over here, so we pick the ground and we put this in the schematic. We click and drive over here. And actually I'm going to blow it up a little bit so I can hook it up. Okay, now we got a hook supply to it. So we know that's a 5 volt supply, so we insert that in the schematic. So we come over here and alright, now we got to tell, so let me stop it here and we'll pick up in the next video. So so long till next time.